Hello learners, I welcome you all to this video program on oceanic circulations tides part 1. In the previous video programs we have studied about hydrosphere, different realms of hydrosphere and hydrological cycle. You have also learnt about bottom reliefs of oceans and we have covered in detail bottom reliefs of different oceans or the major oceans of the world. Then we have studied the two important physical properties of oceans like temperature and salinity. So now you know the distribution of salinity and temperature in the oceans and the factors affecting it. And in this video program we are going to study about oceanic circulations. Oceanic circulations play a significant role in maintaining the equilibrium in Earth's system. So various oceanic circulations like waves, currents and tides need to be studied both significantly and strategically for continuous monitoring of sea water at different levels and intervals. In this video program, we will get a brief introduction of movements of ocean water or oceanic circulation in the form of waves, currents and tides. Then we will have a detailed discussion about tides, like we will study the origin of tides and we will also study the different types of tides. And in the next video program we will continue with the different types of tides and different theories related to the origin of tides. So first let us start with a brief introduction of waves. So what are waves? When you go to the seashore or if you are an inhabitant of ocean coastal area, you must have noticed different types of oceanic circulations. So waves represent undulations of sea surface having crests which are the highest portion of the wave and the trough which is the lowest portion of the wave, and these move in succession without actual movement of water. So waves transmit energy, not water, across the oceans. If you look into this figure, you can see the topmost portion of the wave, the crest, and the trough, the bottommost portion, and then you can see different components like wave height, amplitude, wavelength, wave period. In this figure you can see wave height is the distance between the topmost portion of the crest to the bottommost portion of the trough, and amplitude is half of wave height. So it is from the sea level to the topmost portion of crest or from sea level to the bottommost portion of the trough. So you came to know about wave height, amplitude. Now what is wave period? The time required for the wave crest at point A to reach point B. You can see in this figure. And wave frequency is number of wave crests passing a point A each second. This is called the wave frequency. So these are the different terminologies related to waves, and water particles actually rotate in circular orbit beneath each wavelength with a diameter equal to wave height, and waves are mostly caused by wind. So you must have noticed different types of ocean circulations like waves, and you must have noticed the periodic rise and fall of ocean water in the form of tides. So when we discussed waves, you go through this figure and you see all the details, and you also should know that PINNET in 1992 classified waves based on their period, and this is useful in understanding the basic features of physical oceanography. Now wave periods can range from less than 1 second for capillary waves that are generally generated by local winds to the order of 10 minutes or few hours for tsunamis, and then 12 hours to 24 hours in case of tides. So in this figure you see the capillary waves are having wave period of less than a second, and then you can see the storm or earthquake waves are having wave period ranging from about tens of minutes to few hours, and then you come to tides which are having wave period of about 12 hours, 24 hours and even higher. Have you ever watched the seashore carefully for daily rise and fall of sea at regular intervals and the time of sun and moon crossing that meridian? So tides are the rise and fall of sea water or waves with regular period, and these are produced by gravitational forces of sun and moon. Tidal currents affect the whole water mass of the oceans, that is from the top to the bottom. So it is a vertical rise or fall of ocean water, and it involves the entire mass of ocean water, and it is affected by the gravitational forces of sun and moon. Since sun is much greater in size compared to the moon, so you might think that the gravitational force of sun is greater compared to moon, but it happens that gravitational force of sun is 46% lesser than that of moon. That is because moon is nearer to our earth compared to the sun. So moon has a greater effect on the tidal waves compared to the sun. Now come to ocean currents. Just get a brief introduction, otherwise we will deal with ocean currents in another video program. So tides, since tides are vertical rise and fall of ocean water, but ocean currents are horizontal movement of mass of oceanic water in a definite direction. So currents are important because they are able to drive ocean waters to thousands of kilometers. Energy is also transferred through the mixing and transportation of water of different temperatures and densities. And currents are influenced by wind, rotation of earth, which further deflects them, and coastal and bottom topography. These all details we will study in a separate video program. In this we will deal only with tides. As I have told you that tides are originated due to gravitational forces of attraction between earth, sun, and between earth and moon, and tidal force of moon is greater than the tidal pull of sun for earth. Effect of this gravitational pull is observed more on oceans in the form of tidal bulge. And gravitational force of attraction between two bodies. First let us understand that gravitational force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of distance between them. So if the moon or sun is at a farther distance compared to, because when they are revolving and they are maintaining their relative positions, they at times they come nearer to earth and they go farther from earth. So tidal force also varies in this way. Let us understand how tidal bulge is created. When the surface of earth faces the moon, it experiences maximum gravitational force of attraction of moon compared to the center of the earth, because center of the earth, think that this is earth, this is the globe, and this is the surface of the earth, this is the center of the earth. And when the moon is, when this part of meridian is falling directly under moon, so it will experience a tidal bulge because of the gravitational force of attraction at the surface is more compared to the center, because center is at a distance place, and I have told you that this force is inversely proportional to the square of distance between them. So the center part will experience lesser force of gravitational pull of the moon compared to the surface, so a tidal bulge is created on the surface. Oceanic water facing the moon is attracted or pulled towards the moon and high tide occurs. Tidal bulge also takes place on the opposite side of the earth due to centrifugal force, which is a reactionary force of the centripetal or the gravitational force. So this part of the earth facing the moon or coming directly under moon's meridian will experience tidal bulge, and the similar tidal bulge will be on the exactly other side of the earth, because at this portion centrifugal force, which is a reactionary force of centripetal or gravitational force, will be more active, and so a bulge will be created on this portion. You can see in this figure, this is the direction of the moon, and so a tidal bulge is created along this direction, a large high tide you see, and then a similar high tide is created on the opposite side of the earth also. So every place experiences 2 high tides in a day. Obviously, if one high tide it will experience when it will face the moon, and the second high tide it will experience when it is directly on the opposite side of the moon's meridian. So one during the time it faces the moon, and other after 12 hours. So this portion of the earth, it will take 24 hours to reach this portion once again, but it will experience second high tide only after an interval of 12 hours. It is actually 12 hours 25 minutes. This I will explain. Come to this figure. There is a time lag of tides. Suppose a portion A in this figure, as it is shown, it experiences high tide, and then it rotates and come back to position A. Rotation of earth is taking 24 hours. So A will come back to the position A exactly after 24 hours. But at this time, the moon is also revolving round the earth. So earlier the moon was at position C, but after 24 hours moon is at position D. So the place A will have to travel another AB distance. You see in the figure, AB distance to directly come under moon, which is now at D position. So this time actually takes 50 minutes. So after 24 hours 50 minutes, it will place A will come directly under the moon, and then it will experience high tides. But it will experience the second high tide when it is exactly on the opposite side of the earth, that is only after 12 hours 25 minutes. 24 hours 50 minutes, you divide it by 2, it is 12 hours 25 minutes. So the second high tide at A, at place A, will be on the opposite side when it reaches after 12 hours 25 minutes. So this is the time lag, which you might get numericals related to this, and you will be now able to solve. Now let us also understand the lunar months. A sidereal month is a time the moon takes to complete one full revolution round the earth with respect to other celestial bodies or stars which are considered to be permanent, and it lasts for 27.32 days. However, since earth is constantly moving along its orbit about the sun, the moon must travel slightly more than 360 degrees, just as I explained in the previous slide, the time lag. So it also happens to be similar to the in case of moon, that when moon is revolving around the earth, to come back to the same position and get new moon, it must travel more than 360 degrees. So this is called synodic month, which is slightly more than the sidereal month, and it lasts for 29.531 days. So this thing must be clear, that earth is also revolving round the sun and moon is revolving round the earth. So to get new moon again, or to complete one complete revolution around the earth, moon must travel more than 360 degrees, because earth is also moving along its orbit about the sun. You can visualize this and you can understand this, that that's why synodic month lasts 29.53 days. Now let us understand the type of tides. There are different variations related to the effects of rotation, revolution, declination of Earth, Sun and Moon, which produces various short term and long term variations in the tide, in the tidal forces. So, there are different types of tides, and we will study some of these types, like based on daily variation, fortnightly variation, monthly variation, yearly variation and long term variation. Based on daily variation, tides are of three types: diurnal tides, semi-diurnal tides and mixed tides. And diurnal tides, as the name suggests, it occurs at an interval of 24 hours 50 minutes. Semi-diurnal tides will occur at an interval of 12 hours 25 minutes, and mixed tides, it is seen in mid-latitudinal areas where high and low tides alternate with unequal wave height and wave period. You can understand this with the help of this figure. Like diurnal tides, you see one high tide and then again one high tide. It takes about 24 hours 50 minutes. You can see the horizontal which is horizontal axis, which is shown time in hours, 0 to 24 hours. So, high tide to high tide takes about 24 hours 50 minutes, whatever it is. And then semi-diurnal tides, you see that the high tides to low tides and then again high tide takes about 12 hours 25 minutes. So, these are semi-diurnal tides, and mixed tides are having various varying amplitudes of high tides and low tides, and there may be various reasons for it, and these happen mostly in mid-latitudinal areas. Let us understand the fortnightly variation of tides. Since moon completes one cycle around the earth in 29.5 days, which I explained, it is a synodic month. So, based on this rotation, revolution of moon around the earth, there are various positions of moon which I will explain in this figure. You can see the first position is that sun, moon and earth is all in the same line. So, this position is called syzygy. So, all are in the same line, and when moon is in between the earth, that is both sun and moon are on one side of earth, it is called conjunction position. And when moon is on the other side of earth, that is earth is in between the sun and moon, it is called the opposition position. And both these conjunction and opposition positions are called syzygy, and that is they are all in the same line, and so their gravitational force of attraction is towards each other. And so, in these cases tidal we get spring tides, which records higher, about 20% higher than normal height of the tides. And when the moon reaches the first and third quarter of its cycle, its position becomes perpendicular to the sun. The moon's angle is 90 degrees with respect to sun. So, tidal forces work opposite to each other, and in this case we experience neap tides, and these are 20% lower than the normal tides. So, this is the fortnightly variation in the tides, and I'll stop here. We'll study more about different variations in tides in our next video program. So, let us have a quick recap of what we have studied in this video program. We have got a brief explanation of waves, tides and ocean currents, which are different ocean circulations. And we have studied how tides originate, and we have also studied that we have also learned about the time lag between the tides, that is they are not exactly 24 hours but 24 hours 50 minutes or 12 hours 25 minutes as this time lag. I have already explained this. And we have studied some of the types of tides based on diurnal and fortnightly variation. In the next video program, we will continue with different types of tides and different theories related to the origin of tides, because simple gravitational force is not enough to explain the origin and the propagation of tides. So, different theories were given and we will explain these in our next video program. So, it is going to be quite interesting, learners. So, keep watching. Thank you.